Hello, welcome to Algebra 2 Trig, Unit 1, Lesson 3. So this is just going to be a brief summary of Unit 1, Lesson 3, which is all about transformations. So if you have not done the warm-up and each task, I believe there are 4 tasks, you should pause right now and go through those on your own because I am not explaining. I'm not going to go through the tasks. So you should try them. They're meant to be exploratory. You're meant to be doing those on your own and trying to figure it out. And so I would try it. You need to think a little bit first for yourselves. You could look at the answer key to check your answers, check your work. But please do not expect me to take you through that. That is really meant for you to discover on your own. So go ahead and do that. And when you're done and you get to the big transformation equation, then you can come back here. Or if you don't need to at all, that's fine too. But if you do, you can come back to the video and check and see how you're doing. So this is the big transformation equation. I'll probably refer to the letters A, B, H, and K throughout the year. So what do these letters stand for? Well, I just want to summarize, and there's a chart right below this in your notes that you can also refer to, but I'm going to go ahead and summarize it here as well. So this letter A, this little A, letter A in front, if you did task number 4, I believe it is, was associated with letter A, and letter A, maybe it was task number 3. Letter A is associated with a vertical dilation. It could also impact the reflection if you have a negative sign in front of that. It could also refer to the vertical reflection. And when you're doing a vertical reflection, that means you're reflecting it over the x-axis. So these values, letter A and letter K, these impact the y values. So letter A is a vertical dilation, and then you need to tell us it's by a factor of whatever that number A is. So vertical dilation by a factor of A. And then if it's a negative sign, it's a reflection over the x-axis, or a vertical reflection. Letter K is also associated with vertical movement, and this only affects the y values, and this is associated with the vertical translation. And so when we say vertical translation, you're really going to use the words probably up and down by K units, right? So it's going to go up so many units or down so many units. If it's plus K, it's going to go up that many units. If it's minus K, it's going to go down that many units. Okay, so that leaves us B and H. So B and H are associated with your horizontal movement, your horizontal impact, which is your impacting your x values. So B is a multiplier right there. So that is associated with a horizontal dilation. And your horizontal dilation means it's going to stretch or shrink, but it's a horizontal dilation by a factor of 1 over whatever B is. So if B was 2, it's actually going to get half as wide as its original. If B is 1/2, then it's going to get twice as wide as the original. So it's a horizontal dilation by a factor of 1 over B. So this right here is a B. So the things on the inside, the B and the H, are kind of the opposite of maybe what you thought was going to happen actually happens. If this is a plus H right here, it's going to be going to the left. If it's a minus H, it's going to go to the right. So the H, regardless, is associated with a horizontal translation. And those vocabulary words are going to be probably right and left that you're going to use to describe that horizontal translation. And again, it's going to go right if you have a minus H, and it's going to go left if you have a plus H, and then you're going to go H units to the right or to the left. And you should see that as you practice in your homework and as we go through the next few examples. And so here's the chart. That is your transformation summary. You can see here if we have a negative in front of the function, then that is associated with a reflection over your x-axis, which is a vertical reflection, right? If you have a negative on the inside associated with your x, if it's inside the parentheses, anything inside the parentheses is associated with horizontal motion. That would be a reflection over the y-axis because that's horizontal. Again, going back to the outside, those are associated with y values, so the a and the k, right? And it's just going to be compressed vertically by a factor of a, really? And then with our b, it's a reciprocal, not the opposite, sorry. So if it's associated with this, it's going to expand, or it's going to dilate. We're going to use this word dilate, not expand or compress. So it's going to dilate by a factor of 1 over b. This is going to dilate by a factor of a. And then, of course, we have our up movement and with plus k, and then our h tells us if we're going to translate left or right, so it's horizontal. So let's get to some examples right here. So our example number 3 says the point 2, -5 is on the graph f of x. So remember, this point 2, -5 is really the x coordinate of a point and a y coordinate of a point. Find the coordinates of the corresponding point after f of x has undergone the following transformations. So these are the transformations that the original function, is going to go through. So we have transformations that are going to impact the vertical movement of this point, and we are going to have transformations that impact the horizontal movement of this point. So remember, anything on the outside of the parentheses is associated with vertical movement. Anything on the inside of the parentheses is associated with horizontal movement. In the same regard, well, y is what's going to be impacted by vertical changes, and the x coordinate is what's going to be impacted by horizontal changes. So let's go ahead and actually make these impacts. The other thing you need to remember is I forgot in that chart, it had reflect, and then it had dilate, and then it had translate. These are actually the order in which you should make these transformations happen. So first you should reflect, so any kind of negative signs that are going to impact your reflection, you should do those first. Then you should dilate, so this is the order in which you must make the transformations happen, or you must write them on your paper or describe them in this order. And then lastly, it's to translate. So right, left, or up, down. Excuse me. So our y value. So we have a reflection here, and then we have a translation here. So I'm going to take my y value, which is -5, and I'm going to reflect it over the x-axis. Well, when I reflect it over the x-axis, then my y value is going to go from a -5 to a +5, right? So I am going to take my 5, my -5, and I'm going to multiply it by -1 because of that reflection. So the point 2,5 now becomes, 2 -5 now becomes 2,5. Then I'm going to look for dilations. Well, I only have one dilation. It's this 3 here. That is a multiplier. So 3 times the quantity of x plus 4. So that is impacting my x value. So now I'm going to take the 2, right? So now what is my new point going to be with that multiplier? Well, remember, when you have a horizontal dilation, we have to dilate by its reciprocal. I don't even know if I said that word, sorry. So we have to dilate by its reciprocal. So if we're dilating by 3, or sorry, if it has a factor of 3 in front of that x plus 4 quantity, I don't multiply my 2 by 3, but instead I multiply by its reciprocal. So the reciprocal of 3 is 1/3, so that is why I'm going to multiply 2 times 1/3. So 2 now becomes 2/3, and the 5 just stays the same because there was no impact to my y value. Now the last two I have are translations. So I have a translation associated with the y value. So my 5 is going to subtract 2 because that's a -2, and that would become 3. And then I have my x value. So what's happening to that? Well, this is a +4, but if I have a +4, you actually do the opposite, right, with your horizontal. So instead of going to the right 4, I'm actually going to go to the left 4. So I need to subtract 4 in order to shift 2/3 to the left 4 units. Now 4 is the same as 12/3. So 2/3 minus 12/3 is -10/3. Or you could put -3 1/3. If you knew that, that's fine too. So my final answer for this point after those transformations would be -10/3, 3. All right, moving on to example 4. At any time, if you think you know how to do these questions, I would encourage you to pause and try them on your own, right? You don't need to wait and go through each step with me. Try them on your own and then have a listen or have a look at the answer key. And if you didn't get the same answer as the answer key and you're not sure what happened, then you can listen to the video. Otherwise, if you're just confused altogether, of course, you can just keep listening to the video. So here we have a graph, example 4. We have this graph of g of x over here to the right. It says state the transformations that map g of x onto this function y, where we have these two transformations that are taking place. So remember we had the order r dt, so we need to indicate any reflection first, then a dilation, then a translation. So we don't have any negative signs, so there aren't any reflections. So now I'm going to go to the dilation. Well, dilation is a factor that's being multiplied either vertically or horizontally. I have this 2 in front, and so that 2 in front means I'm going to make, this is associated with vertical. So step number 1 is I have a vertical dilation by a factor of 2. So you have to tell me that it's a vertical dilation, and then you have to tell me what the factor is. So vertical dilation by a factor of 2, or just by 2. Sometimes you might see VD by 2. So vertical dilation, you have to indicate if it's vertical or if it is horizontal. So the 2 is taken care of. Now the only other value we have is the +3. Well, that is associated with the translation. So step number 2, because we've exhausted our dilations, is to do our translation. So remember, with the inside the parentheses, we do the opposite. So instead of moving to the right 3, which you might think is supposed to happen, we're actually going to move to the left 3. Or you could say translate to the left 3 units, but left 3 is fine. Okay, so now part B asks us to sketch this graph given these transformations that have taken place. So I need to take each point and vertically dilate each point by 2, and I need to shift each point to the left 3. So we have 5 points here, 1, 2, 3, 4, 5, and we need to do each point. So I'm going to start with 0, 0. So if I look at this and I made a table, I have point 0, 0. Well, if we kind of approached this each point the way we did it previously, I'm hoping you don't need to make tables, but if you do for now, that's fine. So this step number 1, that's associated with vertical dilation. So remember what we did last time to get our new point is we would multiply this by 2. And of course, if you have a 0 for your new function, 0 times 2, it just remains 0. So my y value, the distance from the y-axis, the distance from the x-axis can't change, it just stays 0. And my x value, I have to shift to the left 3 units. So if I'm going to shift this point to the left 3 units, that just means I'm going to take the 0 and subtract 3. So this becomes -3. So all I do is take this point and go left 1, 2, 3 units. So that's where my new point is. Excuse me. So I'm going to do this again with the other point. So what if I look at this point right here? Let's use a different color. We'll use blue. That point right there is 1, 1. Well, for each y value, I have to do this vertical dilation by 2. So I'm going to multiply the y value by 2. 1 times 2 is 2. And I'm going to take my x value, and with each x value, I have to shift to the left 3 units, which means subtract 3. So that becomes -2. So I have to double the distance from the x-axis because that's stretching it twice as high. So this is 1 times 2. Up here twice as high, and then I have to move to the left 2 units. So this is my new point. So that goes to there. I'm going to do the same thing with the next point. So I'll choose this -1, 1. So what do we have to do? Well, we just said we have to double the vertical dilation. So that's twice as high. So that becomes +2. And then what do I do With my x value, I have to shift to the left 3, so that becomes negative 4. So this point doubles its height, so it goes up twice here, and then it goes to the left 1, 2, 3, so this is the new point. So I see my blue one is wrong because I only went left 2, so left 1, 2, 3, apologies. So that's my blue point. So you can see here I have this point, I have this point, and I have this point. Now I'm going to get these last two. So this has a distance of 4 units. I'm going to double that distance to go up here to 8, and then I'm going to shift to the left 3, 1, 2, 3. So that's going to be this point. And then finally, this point here, I have a distance of 4 units from the x-axis. I'm going to double, excuse me, that distance vertically, and then I'm going to go to the left 1, 2, 3. And so here are the 5 points of my new parabola. So it should look like that. Now let me erase the other ones because I got a little messy through here. So it should look like this in the end. So you can see your new graph. So those y values have all been doubled in their height, right? So this distance was 1, now it's 2. This distance here was 4, now it's 8. And then, of course, all of them shifted to the left 3 units, left 3 units, left 3 units, etc. Twice as high. And finally, example 5. Excuse me. You can try to go through this on your own, but we'll go through it step by step here and see how you do. So it says the graph f of x undergoes several transformations to create g of x. So here's my original, my f of x is the solid graph, and then my g of x is over here, it's my dotted graph. So it says letter A, does g of x have the same shape as f of x? If not, what dilations must occur? So does it look like it's the same shape, or has it been stretched or shrunk or expanded or compressed to kind of distort it a little bit? So if you're not sure, then you need to have some kind of strategy to help yourself figure it out. And so what I would do is I would count, this is my original function here, this f of x, and I have this point down here at the very bottom point, and I have the very top point. And I'm going to count the distance between these points, the vertical distance. So the vertical distance is just 1, 2, 3, 4, 5, 6, 7, 8 units. So the original distance from the maximum point of this graph to the minimum point of this graph is 8 units. Well, let's look at the new graph. So here's the maximum of the new graph, and here's the minimum of the new graph. So if I count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I see that it's not the same. So let's go back to the question. Did a dilation occur? And your answer is yes. Yes, it did occur. What kind of dilation occurred? Well, a vertical dilation certainly occurred because it's a higher distance here. This is 12 units instead of 8. So a vertical dilation occurred. Now, how about a horizontal dilation? Do we know if a horizontal dilation occurred? Well, let's figure that out. So if I look with my leftmost point to my rightmost point, then I would see that it's 1, 2, 3, 4, 5, 6, 7 units. And then if I did that again with my dotted graph, I have my leftmost point to my rightmost point. So that's 1, 2, 3, 4, 5, 6, 7. So there was no horizontal dilation, just a vertical dilation. Okay, I've cleared the graph, so we can do letter B. So letter B says, does g of x have the same direction, quote unquote, direction as f of x? So if not, what reflection must occur? Well, hopefully you're saying, no, it's not the same quote unquote direction. On the original one, I had this little hook on my right-hand side. Now in my new graph, the g of x, I have the hook, or whatever you want to describe that as, on the left-hand side. So there's clearly been a reflection. Now, what type of reflection would you call this? Hopefully you're saying to yourself, that's a horizontal reflection. And a horizontal reflection is a reflection over the y-axis, right? So it's a reflection over the y-axis, which means that all of your x values that were positive now become negative. So our f of x becomes f of negative x. So this x becomes negative. Okay, and then letter C. Letter C says, how would the graph of f of x look after the dilations and reflections you observed above? So we're going to go ahead and try to sketch the graph with these reflection and with the dilation. So you should pause and try it on your own, and then unpause and see how you did. Okay, if you're not sure, you can just follow along with me. But one of the things I forgot to write down before I erased everything was what the vertical dilation factor was. So we had that distance of 12 over here, and we had this vertical distance of 8. So the new distance, new height between the maximum and minimum was 12 units, and the original was 8. So you take the new over the original, and you get 12 eighths, and you can reduce that to 3 halves. So in other words, it grew 1.5 times taller than the original. So I'm going to take each point and I'm going to stretch it 1.5 times further from the x-axis because it's a vertical dilation. And then I'm going to reflect it over the y-axis. So let's start with the 0 because that's the easiest one. So here's my original point. Excuse me. When I do a vertical dilation, I can't stretch it anywhere because I multiply it by 0. 3 halves times 0, it just stays 0. But then I reflect this point over the y-axis. So this point goes over here to the left-hand side. So that point's done. Now I'm going to take this point here. Okay, this distance is 3 units. So 3 units times 3 halves, that's 9 halves. Well, 9 halves is 4.5. So I'm going to stretch that to 4.5 times its original. So that's going to go up 1, 2, 3, 4.5. It's here. And then it's 2 units away from the y-axis. So now I'm doing the horizontal reflection. So I'm going to take this point, I'm at 4.5, and I go 2 now because I have to reflect it over here. So this new point is going to be here. Sorry, I stretch it up twice up here, and then I go 1, 2, 3, 1, 2. So I'm here. Okay, so these 2 points have been done. Now let's choose this point. Let's choose another one. How about this point here? So this point here is 4 units, 1, 2, 3, 4. So I'm going to take the 4 units. That's the distance from the x-axis, 4 units in height, and I'm going to multiply that by 3 halves. That becomes 12 over 2, which is 6. So stretching that vertical distance 1.5 times, that 4 becomes 6, so 4, 5, 6 right here, and then I have to reflect it over my y-axis, so that's 1 unit away horizontally, so I go 1 unit away, so that point is now going to be here. So I'm going to be right here like this. Now, as you're doing this, you might want to connect. So these 2 points right here were the little curvy connection, and this point became this one, so I need to connect that directly here. And now you could either look geometrically, so these points are 2 units away, so I can go 2 units away and say my next point's going to be here. And so this point's done. Now I'm going to do this last one down here. So this is a vertical distance of 4 units, so I'm going to multiply that by 3 halves, so it's going down 4 units, so I'm going to go down 6 units, so it's going to be 5, 6, and then I reflect 1, 2, 3, 4, 5, and I reflect 1, 2, 3, 4, 5, so that point is now going to be here. So I'm going to connect these right here. So let me erase. I've got a lot going on. It's a little bit hard to see, but hopefully you didn't draw all this stuff on there. So this is what your graph should look like after I have done the vertical stretch and the reflection over the y-axis. So you'd think it'd be on top of the dotted line, but it's not. So if it's not lying on top of the dotted line, then that means we have one more thing that we need to consider, and that is our translation. Well, you can see every single point is 1 unit away, right? Exactly 1 unit away. Here's a point here. So 1 unit away vertically. So yes, there is a translation, and we're going to move it up 1 unit. So that's your last part. It's going to be up 1 unit. And so now we have to put that together by writing an equation. So it says write an equation for g of x in terms of f of x. So we're going to say g of x equals, and now we need to have g of x in terms of f of x. Well, the first thing we have is we have a dilation. It's a vertical dilation by 3/2. Remember your vertical dilation, you put the factor in front of that f of x function. So that's in front. So we have our 3/2 there. Then we have a horizontal reflection. Remember your horizontal reflection impacts the x values. All of your x values become negative. So we make the x values become negative. So I have my negative sign with the x inside the parentheses because it was a horizontal reflection. The last thing we did was we went up 1 unit. Up 1 unit is a vertical relationship, and so that has to go on the outside of the parentheses. So that's out here, and it's up, so that means we have +1. So my new function for g would have these impacts here. So it would have a vertical dilation of 3/2, reflection over the y-axis, and up 1 unit. So this is your answer here. And that's it. So practice with your homework or those practice problems. Please come ask your teacher, ask me. If you have any questions, go to the library, see the tutors on the second floor, or make an appointment with us teachers. We'd love to help you as well, or ask questions during class. Hopefully this helped, and I'll see you soon. Bye.